So, new week, new information. So the very first thing here, phones away. The very second thing. What is this picture?
The arrow.
There is no right or wrong answer. What was what?
It's space. It's nothing.
It's definitely
galaxy.
space.
It's galaxy. It's the big thing. It's a galaxy.
It's bigger than a galaxy.
It's a black hole.
The Big Bang.
It's got to do with black holes.
Galaxy.
Bigger than the Milky Way. Bigger than the galaxy. The universe.
The entire universe.
The entire universe.
I literally said that.
This is a picture.
I wondered about that. The
You
upside
can't
down.
take a picture of
The upside down.
This is a picture of the entire known universe.
It's known.
Known that we known you
Does it
This
go,
is-
is it infinite? Like, does it go on infinitely?
As far as we're aware, the universe is not infinite. There is a point where you reach the end of the universe.
How is it?
How is it physically possible?
Because they have to. So what they did here is they took a using the Hubble telescope. Is they took a very long. What's it called? You take a picture over a long time.
They sent the
Kind of, yeah, like a time lapse. So they took a time lapse and gave the Hubble telescope a long time to capture this image, so it could collect enough light to make it. Some of it is from that. Some of it is also computer generation. It's not like they took a camera and they're like, the universe is massive. The universe contains everything. Everything that has ever existed, ever will exist.
Does it go on infinite? Like,
The universe is not infinite.
it's not?
No, I thought it was around this time.
And the reason why is the idea of the multiverse theory, where there are multiple universes. There are infinite numbers of universes outside of our own universe. So the way, you guys know who Neil deGrasse Tyson is?
Yeah.
Nope. Neil deGrasse Tyson is a really important scientific figure. He's kind of like Bill Nye, the science guy. He's really good at being a spokesperson for science in politics and other things. So the way he kind of puts it is there are an infinite number of universes outside of our own universe. So you could think of this bucket of different types of balls. This one ping pong ball is our universe. You could pick up and grab another universe that contains an entire universe on its own. An infinite number of universes outside of our one massive universe. It's like a sea of ping pong balls. Each ping pong ball, its own universe.
What if there are other humans living in other universes learning about the other?
If there is an infinite number of universes, then statistically it's likely that there is an exact replica of you that has somewhere in another universe that is just maybe a slightly different from you. Maybe instead of wearing a tie-dye shirt on this exact day at this exact moment, they wore a football jersey instead. And that might be the only thing different. That might be the only thing different between yourself and that self of you in a completely different universe.
What if they're learning about other universes?
The universe and existence is massive, guys. And it's awesome to think about, and it kind of blows your mind at how big it is. And then you can think of it as the reverse, where we go backwards. So we're going backwards. We're thinking huge like the universe. Now we got to think of something as teeny tiny as an atom. Super small as an atom. You have more atoms in your own body than there are stars in the universe.
No. Yeah. Prove it.
Wait,
I really want to hear that, sir.
we have more.
There are more atoms in your own body than there are stars in the universe. And the universe is massive. So, kind of your mind-blowing thing for the day.
We're
bigger than you.
So, let's look at another picture. What's this picture?
What year?
This one is the Big Bang.
No, that's a big mortar.
Is that from Star Wars?
If it's a Big Bang, how'd you
This is absolutely 100% a computer generated
I was
photo.
gonna say, I really want to know what I want to hear this.
This is not. This one is not a real photo. This is a computer generated photo of the Big Bang. Who knows what the Big Bang is?
A
TV
theory.
show.
It's a TV show. It's a theory.
It's a TV show.
The Big Bang is the beginning of all known time. At the be- yeah.
Isn't that a theory that multiple universes collide to create our galaxy?
All started with the Bang.
Bang.
It's something like that. I think I might have the words.
A universe wouldn't collide to make a galaxy, but you could have multiple universes colliding with each other.
What's a galaxy? I don't remember.
A galaxy is just a cluster of like stars. A large number of stars. The Big Bang was the start of time. At the beginning of time, there was an object about the size of a marble. The densest object ever known to exist. It was infinitely dense. It was about the size of a marble. It got so dense, it kept compacting and compacting and compacting until finally it couldn't compact anymore. It was so incredibly dense. Essentially, it was a super mega black hole, and it exploded. It exploded outward. And that outward explosion led to the creation of the universe. It led to all the stars that we have, the planets, galaxies, all of it, because of this. Because of this Big Bang, this explosion that happened around 13.5 billion years ago. And the reason why we know that the Big Bang happened 13.5 billion years ago is we can track starlight. So we can look at starlight, and we can see currently stars that are 13.5 billion light years away from us. If we try to see a star that was 16 billion light years away from us, we couldn't see it. Because there hasn't been enough time for that light to reach that star that's 16 billion light years away from us to get to us. There hasn't been enough time yet for the light to get here. So that's how we know about 13.5 billion years ago the universe started. Because there just weren't any stars there at that point. It hadn't reached us yet. Because we haven't been around long enough. We've only been around 4.5 billion years. In the grand scheme of things, 4.5 billion years compared to the age of the universe is about 1/3 of it.
Yeah, so I'm like 9,000 years old.
What? So this week we're going to talk about how we classify matter. But what does matter have to do with the Big Bang theory? The Big Bang. What does matter have to do with it?
I don't know what you do.
What does matter have to do with the Big Bang? Part of it? Where does all matter originally come from?
Something.
The Big Bang.
All matter that makes up you, the atoms inside the table, inside me, inside your parents, your dog at home, your cat, the trees outside, the ground, all matter that is created and exists originated from the Big Bang. Supermassive explosion shot all that matter out. So today we're just going to kind of focus on this composition of matter. Like, how do we classify it? Because there's an infinite amount of matter. We have to organize it some way or form. So one of the first things we do is we organize it based on if it's an element or not. So element would be like something found in the periodic table. That's the periodic table. Anything in there on that on the periodic table, that is classified as an element. It is a substance made up of atoms of the exact same as all the other atoms. They are exactly alike, they are not different. So if you have an element of gold, you are very rich, you have a lot of gold for some reason, just lying around your house, and you had a clump of it, you would have an element of gold. Or you would just, gold would be an element because it's pure. All the atoms in it are exactly alike. They are not different. What other elements? Those of you in shop class. Metals. What other metals do you use in shop class?
Fire, water.
Tungsten. Or what did you say, tungsten?
Greenwood.
Welding sticks. What kind of metal is that made out of, do you know?
That is steel.
So steel. So steel, is that an element?
No.
No.
It's a mixture.
Steel is a mixture of what two?
Iron and copper.
Iron and not copper. Iron and carbon is what steel is. Iron and carbon. Iron, Fe, an element. Carbon, C, an element mixed together to make.
Isn't carbon air?
Carbon is a gas.
Oh, okay.
Tungsten is the middle with the highest most.
So when we have an element, it's considered pure. There aren't any impurities in it. There's nothing else but the atoms. They're all exactly alike. We also can do a pure substance. So a pure substance would be a type of matter with a fixed composition, meaning it is all made up of an element, or it is a compound, meaning we have a combination of elements put together to make a pure substance. So we might have liquid water. When you drink a glass of liquid water, you're drinking a pure substance. Every atom in that glass of water is H2O. H2O is a compound. It is a chemically combined hydrogen to oxygen. That is a compound. Two or more elements chemically combined. We get a pure substance. Following me so far?
Yes. Tungsten is just one type of metal. That's a set.
Tungsten is an element.
Oh, is it?
Yeah, tungsten. Right here, W.
Neato. Metal with the highest.
So we had an element. Pure substance. The other pure substance we have is a compound. A substance that is two or more elements that are chemically combined. Mason, if I have something that's chemically combined, can I grab, say if I had water, can I grab the oxygen atom and grab the hydrogen atom and pull them apart with my hands? No. Even if I physically could reach down and pick up an oxygen atom with my fingers and pick up a hydrogen atom with my fingers and pull, they are chemically combined. I can't separate them with my own hands. I'd have to chemically separate them. So things that we talk about every day, that we use every day, might not think about it. Well, I probably don't think about it at all. Nitrogen oxide, water, nitrogen dioxide, carbon dioxide, oxygen gas, the compound, the molecule that we need to breathe. Without oxygen gas, O2, we can't breathe and we die.
Oh.
All the air we breathe is a compound. All the water we drink is a compound. So we have element, we have compounds, which are both examples of pure substances. Now we're going to talk about mixtures. A mixture is matter composed of two or more substances that can be separated by physical means. When I say physical means, what am I talking about?
You can physically separate them.
How?
Take them apart.
I can physically grab something and I can pull it apart. Maybe not all the time, but I can physically do something to it and I can separate it. If we look at this salad here, a salad is a mixture. It's a simple mixture, but it's a mixture. I could grab, if I don't like tomatoes in my salad. I can physically grab the tomatoes out of the salad and throw them away. I can physically separate the tomatoes from the salad. If you don't like olives, this salad here has olives in it. If you don't like olives, I can physically pick the olives out and throw it away. Green or black?
Black is acceptable.
I can't do. I eat green olives over black olives any day of the week.
I know eat.
They're just salt. Basically, who likes dill pickles?
Pick me.
I eat 3 jars of dill pickles a day.
What?
That's a lie. 3 a week. 3 jars a week.
That's a lot.
That sounds normal.
That doesn't sound very
Be
healthy.
careful, children.
Dill pickles have 0 calories. Why do you think I stay so skinny?
So you just eat pickles all day?
I eat a lot of pickles. But anyway, olives are just.
Guess how long it took him? A week.
All right. Pause. Any questions so far? Elements. A substance made out of all the same atoms. Compound. 2 or more different atoms chemically combined. A pure substance is either an element or a compound. And then we have mixtures, okay?
You can pick from these things.
Shh. Guys, if you're on your laptops, unless you're looking at this, you should close them.
Why is there Gatorade?
Gatorade is.
So, couple types of mixtures that we have. Mixtures that affect you every day. You have a homogeneous mixture, also called homogeneous. I like homogeneous because it just flows out the tongue better. And chefs talk about this kind of stuff all the time. Chefs deal with it. Chefs are just fancy chemists that make a lot more money than chemists do. Because cooking is all about chemistry. So if you like to cook, you're a chemist, you might not realize it. A homogeneous mixture is a mixture that remains constantly, uniformly mixed. That just means if I take a swig of that Gatorade, that blue Gatorade, I open it up. I open up the top. I take a drink. The next drink I take will be exactly the same as the first drink. No matter how many drinks I take, it's all going to be exactly the same. Following me? Zoe, you following me? Making sense?
This is a lot at once.
I thought this.
And I know this is a lot at once. Tomorrow, I'm going to give you guys work time for your Learn Smart this week. Wednesday, you'll have one almost every week. Wednesday, we're going to have a lab. I just want to make sure you guys get this information first before you go out and get it from the reading and the lab. Okay? So bear with me. I'm not going to do this all the time. Particles are the same or small enough they cannot be seen with a microscope. So if I were to take that Gatorade, that blue Gatorade, now we're going to waste it, put it on a microscope slide, look at it through a microscope, I could not see the parts of the Gatorade that make it blue. I couldn't do it. I can't see small enough. We also can call it a solution. So if I ever say solution, a solution is the exact same thing as a homogeneous mixture. They are not different. They are exactly the same. Just 2 words for the same thing. Seth, you talked about steel. Steel is a homogeneous mixture. It is an alloy. It's the exact same. It's a solution of metal. Solutions do not have to be liquid. As long as they are exactly the same atoms put together, they're not randomly mixed up, they're organized, they're a homogeneous mixture. Where are my coffee drinkers at?
My hand's gonna go lower. I hate coffee.
Coffee.
What? Coffee?
I'll join cup every now and then.
Lauren, if it helps you, I hate coffee too.
Coffee's the best.
Straight up,
But
straight up
coffee is a solution. Coffee is a homogeneous mixture. You cannot separate it with your hand. If I looked at it under a microscope, I could not see the different parts of it.
You put cream in your coffee?
I don't drink coffee.
Straight up black coffee.
It's just sugar and water though.
Pretty much.
So gross.
What other things in your life that you can think about might be a solution? What other things in your life might be a solution, guys?
Yes.
Tea.
Tea is a solution.
Soup.
Get out.
Barbecue sauce.
Barbecue sauce would be a solution. Ketchup would be a solution.
Mustard.
Wait, I have a question.
Part of ranch is a solution because usually you have like the little bits of like lettuce or whatever's in. I don't even, but it's green. You know what I'm talking about? Little green chunks. So the white part would be the solution.
Question. What's that sauce you get? What's that like you order steak? What's that sauce you get?
A1,
No.
a juice,
Yeah, that.
a juice would be a solution.
Sauce. Mountain Dew.
Mountain Dew is a solution.
I like
Well, this is the solution.
Phone case,
Algebra.
Everyone works for.
if you were to break it down into different parts, there'd be parts of it that would be a solution.
Okay, let's find out.
All right. So now what we got? We had a solution. Same throughout the entire mixture. Same atoms throughout the mixture. No matter what part of the mixture I took from, it'd be exactly the same. We now have a heterogeneous mixture. Heterogeneous. Hetero means two or more. Multiple. That's that magic sand or hydrophobic sand I think you're talking about. A heterogeneous mixture. Guys, heterogeneous mixture has different parts. You can physically see the different parts. So a pizza. What parts of a pizza can we see?
The sauce.
We can see the sauce, the cheese, the pepperoni, the crust. If I don't like pepperoni, then you're weird. If I don't like pepperoni, what can I do to get rid of it?
Take it off.
Take it off. That's how we get a heterogeneous mixture. If I can physically grab it and separate it without having to do something super hard to it, that's a heterogeneous mixture. This oil and water right here, this beaker, are there two obvious, clear, different parts of it?
Yeah.
Yes. Are they still like mixed together? Yeah. Heterogeneous mixture. They're still combined, but they're separated. So like if I wanted to, I could take that oil off. Anyone have an idea how I could take that oil off?
Scoop it out.
You could try to scoop it up. You could try to drain it, drain off the oil.
Take one of those things that sucks things up.
A syringe, yeah, you could take a syringe and take it off.
You know, one of those things that you like, usually in like some sort of an oil where you just kind of drip it down by pressing on the end of it. It's like, I don't know what it's
An
called.
oil can?
No.
What else in your lives might be a heterogeneous mixture? I already showed you one on the slideshow already. You guys, your bodies. Your bodies are a mixture. Your bodies are a heterogeneous mixture. You have what parts of your body that you can separate? Your eyes, your hair, blood, tongue, liver, heart, lungs, brain. All of those different parts, guys. You can go in and separate. And thank God you can. Because otherwise medical science can kind of suck. Because if you were the same throughout and somehow you were magically alive, if something went wrong, how would you fix it?
You need
Wells, what is this?
Game Informer.
Dennis, I need you to focus for a little bit.
Well, I did.
What time does this class go till?
Well, the bell's gonna ring
Okay.
in 2 seconds.
No, we got 4 minutes.
One.
All right, 2 more slides, and then we're gonna do a Kahoot. 2 more slides, and then Kahoot. So guys, I need you to focus. A couple more minutes for me. 4 more minutes is all I need. A suspension is a heterogeneous mixture, meaning you can pull it apart. A heterogeneous mixture where the solid particles in that mixture can settle out. So to have a suspension, you need to have a liquid and a solid part of it.
Wells, you cannot pull out ice cream from a milkshake. No, because you have to blend them together.
I put chocolate milk up here. Has anyone poured a glass of chocolate milk and let it sit out for a while?
No, because then it'll get warm. And if you leave it for
What happens when you let it warm?
All the powder stuff comes down.
Yeah, so if you buy like Kemp's chocolate milk, you don't see this as much because they add something into it. I'm not going to tell you what they add into it.
What do they add into it?
If you have like Nesquik or like Ovaltine and you do it that way, if you let it sit, those solid particles you add in will fall out.
Wait, fall out?
Yeah, like see here, you have your milk, you have some chocolate here, and then at the bottom it gets a little bit lighter. This is that solid part settling out.
What do they add into it?
Yeah, can you please tell us?
Yeah, please, tell
We're gonna
us,
die.
tell us.
I'll just ask Siri.
I'll still drink it.
They add algae to it.
So,
It's a chocolate milk.
Yes, sir.
I don't care.
I mean.
No.
Wells, you want me to click it?
Yeah, please click forward. And then the last slide, the last one. The
After
last
3
thing
more.
is a colloid. A colloid is very similar to suspension, except this time the particles do not settle out. They will stay floating. They will stay floating in the liquid forever.
Are you sure about that?
Yes.
If I dump it out, will it still be?
What if the milk turns into cheese?
Then you've chemically changed it. We'll talk about that later. But if I were to leave that glass of milk out and it were not to spoil, I could let it sit there forever and the solid particles would not fall out.
Wells.
Room temperature.
And there's a test on Wednesday. There's a test we're gonna do that shows us when something is a colloid and when something is a suspension.
Wells, how do you make cheese? Do I just like
age milk.
Do I just like put it in